Alright, so what we're going to do now is an electrophilic aromatic substitution of a substituted benzene. Okay, so I'm going to first of all say of toluene. Alright. Okay, so let's do an electrophile again. I realize we're doing this in simple terms. I'm going to come down here because I want to stay away from that guy right there. It's be equivalent, but it'll be simpler structures, I think, if we start there. Okay. We have one of two possibilities. The E can go here, or the electrophile can go here. Alright, so let's follow both of these out and see which is better. Okay. Yeah, resonance. First of all, I'll draw out the parts I don't have to think about. Okay, my resonance structures are here. If that guy goes there, he stays the same. He's there. He's there. Oops, I should have not done that. I think that's maybe a mistake. He goes there, he's there, and boom. Right? And then he's going to go here, and yeah, that's not going to be there. Be there instead, and there, and boom. Okay, so we have to ask ourselves if we like that structure or not. Before we do, let's go ahead and draw this one out. Oh, you can't see this. This is off camera, isn't it? Okay, sorry about that. Alright, so the electrons move over here, and the carbocation then sort of, by it being really an electron hole, is moved over here. Then the electron hole is moved over here. Okay, let's do the same thing here for this guy. Oh, that's an E. I don't want to draw the hydrogens on there. I want to keep this picture as simple as possible. Okay, so okay, so one of these is the true story. Hopefully you can see all of that, the whole thing on camera. Alright, one of these is the true story. Which of them is better? Well, in order to evaluate which one's better, I'm going to draw out this and say that we had a partial positive here, partial positive here, and a partial positive here. And the E was here. That's sp3 hybridized. So the electrons are shared between all those, but the partial positives are shared there. This is the same thing as this. Okay, over here we'll draw there was a partial positive here, and a partial positive here, right? Okay, that's an sp3 hybridized carbon. So it doesn't get any of the electrons. Do not draw that dashed line all the way around. Do not draw it all the way around. That's sp3 hybridized carbon. It may help you to draw out the extra H there. You may want to do that to save yourself from making that mistake. Alright, now that we know that, we can see a difference between the two structures. And this one over here, we've got a partial positive on a carbon which has an electron donator on it, an alkyl group. That's better. Okay. Now, of course, we memorized that alkyl groups are orthopara directing and activating. Okay? And we say activating because this is actually better than benzene. If benzene were here, if this were benzene, it would not have an electron donator on that, which was sort of the one we did last time. And, you know, so is that good or bad? Well, benzene is sort of the baseline, and with an alkyl group on there, it's even better. So that's why it's activating, because it's better than benzene. It's OP directing because of this also. Okay, ortho-pair directing. Alright, so I'm going to put a big X through this side and say it doesn't go that way. When you're drawing out the mechanism for this, you don't have to show that. But I show it there to, again, sort of teach this. Alright, so the last thing that we have going on is this would never happen if we didn't have the promise of aromaticity regained. So we're going to come here. These electrons come and take that, and this goes, boom. A little bit ugly because I had drawn that bond in there and it got it marked out, but and this goes, and we get para-E toluene. I guess the IUPAC name for this would be para-E toluene. Okay? Or P. It's usually italicized. E toluene. You know that E, right? That's just a placeholder. Okay, I haven't said what E was. Some of you are looking at that and going, there's no IUPAC name for E. You're right. Okay, hopefully that's helpful.